Hi everyone, Dr. P here, and in this lecture we're going to take a look at solutions, in particular a property of solutions known as concentration. And, excuse me, what we need to know about the composition of solutions is how much stuff, solute, is present in a solution involved in a reaction. Excuse me. In the next lecture video, we'll take a look at stoichiometry involving solutions. So in order to do any calculations, we have to be able to quantify how much solute is dissolved in our solvent. So what we are going to do is use the concept of concentration. And in this case, our concentration so we will say amount of solute in given amount solvent. And we can have different units. We could have things like grams per milliliter, stuff like that, but the unit that we're going to use is molarity. And we will denote that with a capital M. That's my capital M there, a little bumpy there, but that's how I draw my capital M's. And the definition of molarity is moles of solute per liter of solution. So that's the total volume including solvent and solute. So our molarity has units of moles per liter. And I want you to get used to interchanging molar and moles per liter frequently. Okay, so 1.0 molar equals 1.0 capital M, which is 1.0 moles solute per liter of solution. We can have things like millimolar, just right here, we can have millimolar, we can have micromolar, we can have nanomolar, and these are typical prefixes that we would use because we would be dealing with really, really small amounts. We're not going to have things like kilomolar. That's essentially impossible to do. Another thing to note is that concentrations are given as though for the original solid. The actual concentrations of ions can differ. So 1 molar NaCl aqueous is 1 molar Na plus aqueous and 1 molar Cl minus aqueous. So it's actually 2 moles per liter of ions. Just half of them are sodium and half of them are chloride. Now we can use concentration and volume to get moles. So we could do calculations. So if we know our concentration, our molarity, and we've got our volume, we can get moles. So let's look at the following. Let's say we want to do a dilution. So we will have our beaker with some amount of liquid in it, of solution in it, I should say. There we go. And we have 1, 2, 3, 4, 5 moles, let's say. and then we dilute. So we'll add H2O. And now we have a new volume, but the important thing is we still only have 5 moles. So our moles are constant. So when we add more solvent to dilute a solution, we don't change the number of moles, we just change the volume. Now if our moles and our volume, if our moles stay the same but our volume changes, our concentration has to change. So we know that concentration, which I will abbreviate CONC, is moles per volume, or our moles equals concentration times volume. So that means in case 1 here, I have a certain number of moles, and that's going to be concentration 1 times volume 1. That equals, so C1V1, concentration of solution 1 times the volume of solution 1, gives me the moles in solution 1. When I dilute, I still have the same moles. So solution 2 is concentration 2 times volume 2. But again, it's because the moles are the same. And you need to remember this. You'll want to remember the dilution equation. Okay, it's very helpful when you are doing actual calculations, as we'll see in the next lecture video. So not just for doing a dilution calculation, but also for doing mole type calculations, stoichiometry calculations. So I can use this, so maybe let's just do an example here. So we could say, what volume of water is needed to dilute a 0.55 molar solution of, give me one sec here. I realized I need to put a piece of paper under here to protect my new desk. So what volume of water is needed to dilute a 0.55 molar solution of NaCl to let's say 100 ml, 100 mLs of, I need an initial volume here. So what volume of water is needed to dilute 100 milliliters of a 0.55 molar solution of NaCl to 0.25 molar. So we'll use our C1V1 equals C2V2. We have concentration 1 is 0.55 molar. Concentration 2 is 0.25 molar. Volume 1 is 100 milliliters, and volume 2 we're trying to solve for that. So what we want is V2, so it's going to be C1V1 over C2. So concentration 1, 0.55 molar, times volume 1, 100 ml, divided by 0.25 molar. And it's important to include your units, all right? You always want to include your units so that you can cancel them and you know you're doing the calculation correctly. So V2 is 0.55 times 100 equals that, divided by 0.25 equals 220 milliliters. But V2 is the total volume, so we need 120 ml added. So it's just the way that this volume of water is needed to dilute. So depending on how your problem is phrased, you'll set up and manipulate your dilution equation appropriately. Maybe you'll have an initial and final volume and an initial concentration, and you need to find the final concentration. You can do that as well. And as I mentioned before, you can use the fact that moles equals concentration times volume to do stoichiometric calculations. And we'll take a look at those in the next lecture video. All right, well, until then, stay safe out there. Bye now.